Assalamu alaikum warahmatullah. Hello my dear students. Today inshallah we're gonna start in unit 1 lesson 2, which is talking about wave motion. What's meant by wave? Wave, it is the disturbance that propagates and transfers energy in the direction of propagation. Like if we see here in this image, if you push a domino, the other dominoes will fall down in the direction of pushing. Wave motion, it is the movement that results from the vibration of the particles of the medium in a specific direction. The line of propagation, it is the direction through which the wave propagates. Now we have here a note. In the wave medium, particles don't move from their position, but they vibrate only. The wave carrying energy in the same direction. Types of waves, we can classify it into two things. Number one, according to direction of propagation in medium, it classified into transverse waves and longitudinal waves. And according to the ability to propagate and transfer energy, mechanical waves and electromagnetic waves. Waves according to vibration of the medium relative to the direction. Number one, transverse wave. Transverse wave, it is the disturbance in which the particles of the medium vibrate perpendicular to the direction of the wave propagation. It consists of crests and troughs. Crest, it is the highest point of the particles of the medium in the transverse wave. Trough, it is the lowest point of the particles of the medium in the transverse wave. Like we see here in this image, the highest point is crest, the lowest point is trough. The propagation of this wave is perpendicular to the wave. Number two, longitudinal wave. It is a disturbance in which the particles of the medium vibrate along the direction of the wave propagation. It consists of compressions and refractions. Compressions, it is the point of highest density and the pressure of the longitudinal wave. Refraction, it is the point of lowest density and the pressure of the longitudinal wave. Like we see here in this image, the point of highest compression or of the highest pressure is compression, and the point of lowest density and the pressure is rarefaction. Waves according to the ability to propagate and transfer energy. Number one, electromagnetic waves. They are a type of waves which have the ability to propagate through the vacuum with a great velocity. Properties of these waves. Number one, they don't need medium to propagate. Number two, they propagate through vacuum. Number three, they are all transverse waves. Number four, they propagate with a velocity equals 3 × 10⁸. Like the waves of light. The mechanical waves, they are a type of waves which can't propagate, or which can't have the ability to propagate through the vacuum, but can transfer through different media with different low velocities. The properties of these waves: number one, they need medium to propagate through. Number two, they don't propagate through vacuum. Number three, they are transverse and longitudinal waves. Number four, they propagate with a velocity much less than electromagnetic waves. Examples of these waves, like the waves of sound. Some concepts related to wave motion and its properties. Number one, wavelength. Wavelength in transverse wave, it is the distance between two successive crests or troughs. Wavelengths can be calculated by this law. Wavelengths equal 2 times the horizontal distance between two successive crests and troughs. So if we see here in this image, the wavelength, it is the distance between two successive crests or two successive troughs. Wavelengths in longitudinal waves, it is the distance between the centers of two consecutive or successive compressions or rarefactions, and it can be calculated as follows. Wavelength equals 2 times the horizontal distance between the centers of two successive compressions or rarefactions, as we see here. Wavelengths totally can be calculated by the distance which is covered by waves over the number of waves. Amplitude of the wave, it is the maximum displacement achieved by the particles of the medium away from their points of rest. It can be measured by meter or centimeter. Amplitude equals the vertical distance between the crest and the trough over 2. Wave velocity, it is the distance covered by the wave in 1 second. Velocity equal distance covered by the wave over time in seconds. Or it can be measured by frequency times wave length, and it measured by meter per second. Wave frequency, it is the number of complete waves produced from a source in a second. Its law is frequency equals number of waves over time in seconds. Periodic time of the wave can be also calculated by 1 over the frequency, and it measured by hertz. Now we have here a note. Periodic time of the wave is the time of one wave.